All right. So, chain rule is going to be the next thing we get into. So, as we're doing differentiation, we've done it in the past where, like in this case, we have two different functions that are times each other. So, this is one of them, and then your sign is your other one. So, when we have two functions times each other, we use a product rule. If they were divided, we use a quotient rule. Here, chain rule, we're going to be another type of that, but we'll talk about it more in a minute. So first, product rule. Remember, it's derivative of the first times the second. So derivative of the first, 3x squared, would go to 6x times the second of sine of x. Plus the first one times derivative of the second. Derivative of sine goes to cosine. And that would be it. All right. Now, where chain rule is going to come in is when we have a function inside of a function. So like here, we have the square root, which is one function, and then inside we have x squared plus 1, another function. Here we have tangent. Normally it's just tangent of a value. Well, now our value is x squared, which makes it another function. So tangent of x squared, we have a function inside of a function. So chain rule goes like this. It's derivative of the outside times derivative of the inside is really what's going on. So f is our outside function, g is our inside function. So like here, g is inside of f. So we first do derivative of the outside with g still by itself, or by, unchanged. We'll go that route. Times derivative of what's inside. So derivative of what that g is. So how this is going to break up is like this. So the fact that this is 1 over x plus 1 makes it two different functions. That inside function, I'm going to allow it to be the u here, is the x plus 1. So the outside function then becomes 1 over u. So the fact that it's on the bottom is one function, and then what's inside it, or what's on that bottom, is the inside. So sine of 2x. So anytime this is not just an x, it is another function. So the 2x is that inside function, so the outside function would be sine of u. So this part here, what I'm doing is just the breaking up, trying to help you with what's going to be the inside function, what's really the outside function. So in this one, outside is the square root part. So the inside is this whole thing of 3x squared minus x plus 1. So the square root of u is one function. What's all inside is another. Now, tangent squared. Here's going to be a little bit backwards. Here the actual inside is the tangent part, but because it's squared, so u squared would be the outside. So if u is tangent, we'd put that in there, we'd have tangent squared. So that's what makes that one the second function. Okay. So sometimes you'll see it here where it's dealing with the power. So really this inside, and I'm going to do it with the u to kind of show the separation, and then I'll go through and do the actual chain rule part of it. So the inside part of this is the x squared plus 1. So that would make the outside then u to the third. So we'd have to use power rule with the outside. Inside we can do just like if it was a normal function. Well, it is a normal function, so that's why. So when we do this, we would do this here. So y prime equals. So derivative of that outside function would be 3. So if I just do this over here, f prime of u would be 3u squared. So that u is still our x squared plus 1. So we would have 3 parentheses x squared plus 1 now squared instead of to the third. So our power rule here, the 3 comes in front, we subtract 1 from it. So this is the first part of it. And then we times, so this is where the chain rule comes in, derivative of the inside. So if we do derivative of x squared plus 1, u prime would go to 2x, and the 1 would disappear because derivative of any constant is 0. So we're going to have a times 2x on this back side. Now, the 3 in front and the 2x we could put together, and so our y prime could be 6x parentheses x squared plus 1 squared. Is how we would write this. So we have to look at it as two different parts, the inside part and the outside part. What do we have to do for the derivative of the outside? What do we have to do for the derivative of the inside? and that's going to be times on the backside. So what we did there is really the general power rule with using the chain rule. So whatever our inside function is, we take our outside power, bring it in front, subtract one from it, and then do derivative of that inside times it on the backside. So if it's u to the n, the derivative of that would go to n u n minus 1 times derivative of that u in the middle, which a lot of letters, probably confusing. So let's do some examples and help it make sense. So again, inside the parentheses here is going to act as our inside function. The outside function is the fact that it's raised to the third. So f prime of x. So the first derivative here. Derivative of the outside function, so the power rule with the third becomes 3, what's in parentheses here, 3x minus 2x squared. And then we subtract 1 from that exponent. So there's derivative of the outside function. Times derivative of the inside function would go to 3 minus 4x. So the x here would disappear since there's no exponent. That's technically x to the first, so 1 times 3 is 3. The x go to 0, 0, anything to 0 power is 1, so 3 times 1 is 1, or is 3, sorry. Back part here, the 2 times the 2 makes it 4. 2 minus 1 is x to the first. A lot of times we don't write the first, we just leave it as an x. Okay? So we could distribute this 3 in, and so we'd end up with 3 times 3, which is 9, minus 12x times 3x minus 2x squared. And that's where we're going to leave this at. Now, find all the points of the graph of f of x equals the cubic root of x squared minus 1 squared, for which f prime of x equals 0, and for those for which f prime of x does not exist. So, with this, there's going to be cases where when we do the derivative, it's going to equal 0, and there's going to be cases where the derivative is not going to exist. It's not going to work out. So we're going to have to limit some of those, of the domain. Now, first thing we got to do though is we have to find what is that derivative, so we know what we're even working with. So f prime of x. So here, the cubic root is the outside function. So actually, before we do the prime, let's just rewrite f of x. So I'm going to rewrite this as x squared minus 1. The square, since that's squared, that's the top part of the fractional exponent. The cubic root becomes the bottom part of the fractional exponent. So this is going to be much easier to work with because then we can just use the power rule like we did up top. So now we can do f prime of x. So the 2/3 would come in front times x squared minus 1. 2/3 minus 1 will leave us with a negative 1/3, which we'll deal with in a little bit. Times derivative of the inside, x squared would go to 2x. Derivative minus 1 would just be 0. So 2x and 2, we're going to rewrite the derivative as this. 2 times 2x would be 4x. Because this is to a negative 1/3, we don't like negative exponents, so we're going to move that all to the bottom. So on the bottom then we'll have 3 cubic roots of x squared minus 1. So where do we have to restrict this? Well, if we have x be 0, 0 on top, 4 times 0 would be 0. The bottom here is 0 squared minus 1. We're going to have something on the bottom, but the top will be 0. So on a fraction, as long as the top is 0, whatever will make that 0, that will make our f of prime be 0. So when x equals 0, f prime of x equals 0. So that's answering this first question, is where will this be 0 at? Second part of this is where will this not exist? Well, what will make the bottom be 0 now? Well, whatever's under the square root to be 0, 3 times anything, or anything times 0 is going to be 0, so it doesn't matter the 3 out front. That's where I was going with that. So x squared minus 1, remember, goes to x plus 1, x minus 1. So x cannot be 1 or negative 1 for the second part of that, where f prime of x does not exist. So when x is 1 or negative 1, it won't exist. When x is 0, we're going to get 0 for an x, or for a derivative as well. So looking at this one here, right now it looks like we have a quotient rule type problem, which there's going to be times where you may end up doing quotient rule or product rule with the chain rule. But if we can help it, let's try not to. So I'm going to rewrite this here. So equals, and this is just the little arrow saying, hey, this is going to be the same thing. We're going to transform it. So our negative 7 parentheses 2x minus 3. And if it was on the bottom, moving it to the top will make it a negative 2 for an exponent. Remember, moving from the bottom to the top makes it negative, or top to the bottom would make it negative. It's going to switch the sign. All right, so when we do derivative of this, again, our 2x minus 3 is our inside function. The negative 2 is the outside function. So g prime of x equals, bring our negative 2, and negative 7 make 14. Parentheses 2x minus 3. Subtracting 1 from negative 2 makes us negative 3. Times, we have an inside function here, so derivative of 2x minus 3 would be 2. So when we finalize this here, 14 and the 2 would make 28 on the top. The negative, we're going to get rid of it now and move it back to the bottom after we've done the derivative. So 2x minus 3 cubed would be its derivative. That's how that's going to flow. Questions here? All right, so a little bit ago I said sometimes we got to do product rule. Well, we're going to do product rule here because this x squared is one function. The square root part is another function, but the square root has a function inside of it, the 1 minus x squared. So product rule, derivative of the first, so f prime of x would equal, so derivative first would be 2x times the second part, square root of 1 minus x squared. So just like before, product rule, first one, simple, easy. Second part here, a little more complicated because we're going to have to do the chain rule with the second part. So x squared times, so remember, this square root of 1 minus x squared is really going to be 1 minus x squared to the 1 half. So we can write this as 1 half, parentheses 1 minus x squared to negative half, times derivative of the inside. Derivative of 1 would be 0. Derivative of x squared would be a minus 2x. And that's our second, or derivative of the second part. So the 1 half down, subtract 1, make negative half, derivative of the inside. So simplifying this here, we have 2x. I'm going to rewrite this as 1 minus x squared to the 1 half for right now. Plus, so our 1 half and our negative 2 can cancel, and we can change this to a minus then. X and x squared is going to make x to the third. So then this 1 minus x squared to the negative half, we're going to move to the bottom and make it 1 minus x squared to the 1 half. Now, if you do this with the book, it's probably going to have you try to simplify this all together. So if we get a common denominator of 1 minus x squared to the 1 half, so we would times the top by it, which makes this a full. So 1 minus x squared to the 1 half, on top 1 minus x squared to the 1 half. These would all be factors, so you'd have 2 of these halves, which make a whole. And that's why we're to here. So then we can distribute the 2x in. So we would have 2x minus 2x to the third minus an x to the third for the second part, all over 1 minus x squared to the 1/2. So what I did is I got common denominators here. This one was missing the 1 minus x squared to the half, so you take the top times it. That cancels with the exponents. So then we were able to distribute the 2x in because we no longer have our exponent here holding that part up. So first part, distributing the 2x in, and because they're the same denominator, we can put it all over 1 and subtract the 3 with it on top. So last little things we can do here. So we'd have our 2x on top, a negative 2x to the third, another negative x to the third would be minus 3x to the third. The bottom we're going to put back under the square root and write it as 1 minus x squared. And that would be your answer. So please, as you're going through this, if you need to pause, write stuff down, go back through what I'm writing, please do that. If you need to back it up, watch it again, please do that. Try to help yourself out. Now, if that's still not helping you, then I'm here too for questions. Let me know, and I'll answer them the best I can. All right, so this one, either we're going to have to do product rule or we're going to have to do the quotient rule besides the chain rule. So let's just get this quotient rule out of the way. So derivative of the top would be 1. So we'd have 1 times our bottom. So the cubic root, actually I'm going to rewrite that as x squared plus 4 to the 1/3. So cubic root to the 1/3. So remember that. X squared plus 4 to the 1/3 is the same thing. So then it's minus the top times derivative of the bottom. So 1/3 x squared plus 4 minus, and that would be negative 2/3 times derivative of the inside. X squared would go to 2x, 4 would go to 0. Whole thing is over the bottom squared. So x squared plus 4 squared. Squared in 1/3 would make it 2/3. So, are we having fun yet? So, we're going to simplify from here. 1 times anything is itself. So, out front right now we have x squared plus 4 to the 1/3. Minus. So, let's see what can we put together here. We have 2x and an x and a 1/3. So, this could be 2/3 x squared. So put this together with this, and we're left with x squared plus 4 to negative 2/3. All over x squared plus 4 to the 2/3. All right, so from here, what are we going to do? Well, here's what we're going to do. I'm going to rewrite this top here as x squared plus 4 to the 1/3. Minus 2x squared over 3x squared plus 4 to the 2/3, and a set of parentheses. So this bottom then, if we're going to change this to multiplication, we're going to flip the bottom over. So this is back to leave change opposite, or leave change flip, that we did when we were multiplying or dividing fractions. So we're going to use that part here. So this is going to become 1 over x squared plus 4 to the 2/3. So common denominator for the bottom would be a 3x squared plus 4 to the 2/3. So if we take that times the bottom, we would take this times the top. So we would need a 3 here. The 2/3 and 1/3 would make 3/3. So that would make this part disappear. So the bottom being the same can become one denominator here of 3x squared plus 4. Now, I'm going to do the 2/3 here so that we don't get too far ahead of ourselves. And then I throw you off. So the back part is still 1 over x squared plus 4 to the 2/3. Now on top here, we would distribute the 3 in. So 3x squared, 3 times 4 would be plus 12, minus 2x squared. So when we put this all together now, so f prime of x, our derivative, is going to be this. 3x and a minus 2x, we would be left with an x squared on top. And then 12 has nothing, so plus 12. On the bottom, when we multiply these, we'd still have our 3, but now x squared plus 4 to the 2/3 and x squared plus 4 to the 2/3. Same base, so when we multiply, we add the exponents. This will become x squared plus 4 to the 4/3. And that's going to be as far as we could take this one. Now, a couple problems left. So far, what we've done is product rule, chain rule, where in the process of it, we've had to use a chain rule with either the product rule or the quotient rule. And I said product and quotient, or product and chain there, sorry. So when we've worked with the product and quotient, like on this last one here, as we were doing the quotient rule, we end up doing the chain rule part with the derivative of the bottom part. Or on the last one, while we were doing that product rule, we did it. Here, doing the chain rule will lead to the quotient rule. So it can go the other way as well. So derivative of y, so y prime. We do power rule at the outside, so it becomes 2 parentheses 3x minus 1 over x squared plus 3. The 2 would become a 1, so this is all it has. So now we would times on the back side, so this is doing the chain rule part, derivative of the inside. Now when we do the derivative of the inside, we're going to have to do the chain or the quotient rule with it. So I'm going to do a big set of parentheses. So derivative of the top would be 3 times the bottom x squared plus 3 minus the top 3x minus 1 times derivative of the bottom, which would be a 2x. And the whole thing is going to be over x squared plus 3 squared. So to simplify this down a little bit, so y prime equals, we're still going to leave the 2 out front. However, our x squared plus 3 matches what's on the bottom. So we can write this as x squared plus 3 to the 3rd. We're putting our bottoms together. On top, though, we still have a 3x minus 1 times, here we could distribute the 3 in and have 3x squared plus 9. Here we could distribute the 2x, but there's a minus with it, and have minus 3x and 2x would make 6x squared. The minus 1 minus out front would make it plus. 1 and 2 would be 2x. So, getting closer. So we're going to leave this as 3x minus 1 out front. So x squared, we have 3x squared and minus 6x squared, which make it minus 3x squared. We have a plus 2x. We have a plus 9. Bottom is still x squared plus 3 to the 3rd. And that's as far as we're going to take it. this we could probably factor out. Not going to be an x squared plus 3, so it's not really going to cancel at the bottom. Our 3x minus 1 isn't going to cancel at the bottom. So why FOIL this all in then? We can just leave it how it is. So, questions there. Again, let me know if you have questions. If you need to re-watch or pause something, please do that. All right, so when it comes to trig functions, it's as long as we have just an x there, remember, sine goes to cosine, but it's when we have something else here. So if this is x squared, if this is, say, 3x plus 2, if this is anything other than an x, we have to do chain rule with it. Otherwise, with, say, if it's sine of x, well, derivative of the inside, derivative of x would be 1, so 1 times it is just itself. That's why before, we never worry about chain rule. So if I wrote that out, say sine of x would go to cosine of x times 1, because derivative of x is 1. So 1 times itself is just cosine x. So that's why we never worried about chain rule before. So when that's something other than an x, though, we're not going to get a 1 here times it. So that's why we have to do chain rule with it. So find the derivative of y equals sine of 2x. So 2x is our inside function, sine is our outside function. So y prime would go to this. Derivative of sine is cosine 2x times derivative of the inside, 2x would go to 2. So in the end, y prime is going to be 2 cosine 2x. So if it's something other than an x, we're going to get a different number here, and it's going to mess with it, so we have to do chain rule with it. Now, again, watch for these parentheses, because if it's cosine 3x squared, that's going to be different instead if we had cosine 3x squared, because there would have to do product rule. Here we're doing chain rule. Or if it's cosine 3x quantity squared, typically you won't see this, because if cosine is squared, it'd be here. But there you'd have to do chain rule multiple times, which is where we're going to end up with this one here. So, first off, the cubed is the outside function. The next inside function is sine, which has an inside function of 4x. So there's really 3 functions going on here. So when we do f prime of x, we're going to repeat the chain rule here. So first, our cubed. So 3 sine squared of 4x times derivative of the inside. Well, the inside function is sine of 4x. So derivative of sine would go to cosine 4x times, inside of that, derivative of the 4x would be a 4. So when we put this all together, the 3 and the 4 can go together and have 12 sine squared 4x cosine 4x is what that would go to. So the cubic root's a very outside function, so we did power rule first. Derivative of the next inside is the sine function, so derivative of sine goes to cosine. And derivative of the very inside, then the 4x would go to a 4. So then, because they're all multiplied, our 4 and our 3 are like terms, we can multiply those. The sine squared would be the one factor, cosine would be the other factor. This is as far as we could take this one. Now, there may be problems where you have to find the equation of the tangent line using this. So again, you're going to do the derivative. Whatever x they give you, you'd put that in, and that'll give you your slope. And again, use that point slope form using the point they give you and then the slope that you found to write the equation. So, questions on this, please let me know. If you need to rewatch something, again, rewind it, rewatch it. If you need to pause it to give yourself time to write stuff down, please do so. Always let me know if you have questions. Until next time, we'll talk to you later.